All right, so my name's Dennison Bertram. While you're filling this out, I'm going to introduce myself and then get started. We're basically going to do a workshop today. I'm going to explain a bit about MetaTransactions, the gas stations network, what essentially we're trying to solve, how we're trying to solve it, and then depending on how much time we have, I think this should be an hour and a half, if I'm not wrong. Two? I'm hearing two. Do I hear 2.5 hours somewhere? So we'll see how far we get. Of course, you're always free to ask me questions, come up after, and then we'll go through it. Hopefully the Wi-Fi works. If not, I'll talk us through it and see how far we get. So people have been filling out the poll. Short of hands so I can move on a bit. Okay, great. So MetaTransaction Workshop. GSN, tools, live coding, and more. I'm Dennison Bertram, developer advocate at OpenZeppelin. We work to build developer tools, things to make your life easier, so building on Ethereum can be something we can actually do. That's our website. We recently rebranded, so if you know some of our former products, such as Zeppelin OS, our OpenZeppelin library of audited smart contracts. These may have some new names these days, but we're still the same company that you know and love. So do this first. This hopefully will be running in the background while I'm talking. I'm giving us about a 2-to-1 chance that it doesn't work. But hopefully it does, depending on how your internet setup is and how fast it is, and if we can all npm install at the same time. You don't have to get all of it. I think the most important part is if you can get down to this line here. That's probably going to be enough. So hopefully we'll then be able to do some live coding together. All right, so a lot about what we're trying to do here is deal with the user experience that people are having. And something at OpenZeppelin is very important to us is the user experience and the developer experience, because these two things are intrinsically linked, right? And as you saw with this poll, one of the things that I try to do is I try and collect user feedback and understand how people are using things in the Ethereum ecosystem. So this is from one of my research projects where this is actual footage of a new user trying to onboard to a dApp. Right? We know this experience. It tends to be pretty awful, especially when you find out about a new dApp in some sort of situation where you can't go get ETH, you don't have access to your Coinbase, you're on the subway, so you're not in a position to write down 12 mnemonic words. So what is missing here? What's missing is the user experience, right? And the user experience is a major blocker for us when we're building apps or dApps that people want to actually use, right? It doesn't matter how great our idea is. If our implementation sucks, we're going to be unsuccessful in our attempt to onboard people to our apps. So we lose 99% of our new users at the install MetaMask step in the sign-up process, right? And that's, I think that's from Dapper Labs. They did a study about that for CryptoKitties. Out of every 100 people who come to buy a cat, 99 of them leave at install MetaMask, right? So if you think about a 99% loss rate, that's pretty insane. If you consider how popular CryptoKitties was, if you consider how popular some of the dApps that we have were at the peak, and you imagine that it was only 1% of what people actually wanted, you can get an idea a little bit of the scope of disappointment that we gave our users when they came to our applications. So part of solving that problem is the onboarding. And the Gas Stations Network Alliance is a group that have worked together to build out MetaTransactions. MetaTransactions are a solution to the install MetaMask step in onboarding new users, right? Because you need ETH to interact with smart contracts, it means you actually need KYC. You need MetaMask. You need the 12 words. You need the process that goes on in between that, right? And that is an incredibly huge blocker. I think most of you will probably agree Facebook is evil, and we hate using OAuth to log in with Facebook. But when the opposing choice is, username, email, confirm, I know I'm lazy enough that I prefer just to log in with Facebook, right? Like at this point, our users' attention spans are so short that any amount of friction between them and your application is too much friction. So the Gas Stations Network Alliance, it's been built to try and solve this problem. We believe metatransactions are the solution to this. Originally, it was conceived by DappCon as an idea to help make metatransactions a mainstream thing, and we've worked together to actually, in our opinion, solve this problem. So what is the GSN, or Gas Stations Network? It is a decentralized group of relayers who are paid for relaying transactions. Pretty simple. We have a single audited, by OpenZeppelin, single audited contract for coordinating. It's the relay hub, right? And this relay hub has the same address on every network, no matter where you deploy it. Whether you deploy it on the network you just spun up right now in Ganache, or on the mainnet, right? So this single centralized hub smart contract handles all of the coordination responsible for this. dApps pay for their own transactions, right? So that means that when you create a smart contract, if you want users to interact with a smart contract without paying any ETH, you get to pay the ETH. Yay. Certainly there's a little bit of caveats that we'll go into down the line on that one. But the idea is that the users no longer have to go through that like KYC, ETH, MetaMask hoop. You're taking care of that for them, whether it be the first transaction or all of their transactions, right? Because depending on the type of app, maybe your users are so high value to you, right? Maybe you have a DeFi application where your users are trading hundreds of millions of dollars in some sort of token. Maybe you don't want them to ever deal with the friction of having to like confirm a 15-cent transaction for each step, right? Maybe you want to make it as smooth as possible because that customer is too valuable to lose at these unnecessary friction points. So what does this solve? Just saying this a little bit. Users don't need ETH to interact with your dApp. Developers do not need to roll their own solution, right? Metatransactions are something you can build. You can go out and build a metatransaction system for your app. And of course, some apps who have realized this problem earlier have gone out and done this, right? But if we all are trying to first build our own metatransaction solution before we get to building our own application, half of us are never going to get there. And the other half are going to build something and we'll never sleep well at night because we'll never know if there's a hole in it somewhere, right? Especially when we're dealing with money. The system is decentralized, as Yoav from DappCon likes to say, game theory for the win. So there's a set of game theory dynamics that really address a lot of the complicated aspects of having someone else pay for your transactions. What this enables for us as dApp developers is new business models, right? We can charge users in tokens to access dApps, right? Maybe originally you expect people to pay in ETH, but now you want them to pay in your native token, right? Maybe you have credits that they use. You can pay for DAO transactions from a treasury. You can set up the GSN so that when your users, a member of your DAO, make a vote, maybe they shouldn't need to confirm MetaMask to make a vote, right? Maybe they shouldn't need to pay 10% to participate in your quorum of voters, right? Why should they? The DAO has $1 million in it. Why do I have to pay 10 cents right now just to vote to make sure that participation stays high, right? You can set it up so that the payment for these transactions for interacting with the DAO get paid out of the DAO treasury. Oh, okay. Well, we'll get back to this a little bit later because I have my spiel kind of like mapped out. But why you would want to have users pay in their own tokens? Well, maybe you're Chuck E. Cheese online, right? And now you don't want people to be dealing with ETH, right? Maybe ETH right now, the gas transaction is 3 cents. Maybe it's 15 cents. Maybe it's 50 cents, right? It's not really cool when you're like playing some sort of online skee ball game at your Chuck E. Cheese online, right? Chuck E. Cheese, don't sue me just because I said you. Right? Like, so maybe you want to say, hey, every transaction you make is going to be 5 cents, right? Or 1 Chuck E. Cheese token, right? So now they pay in tokens and you can deduct them for that on the back end, right? But also, maybe you're not even on mainnet. Maybe you're using this metatransaction solution on a sidechain, right? And you want to have something that you can forward the charge to users so they are paying for your service. In that regard, you can accept credit cards for dApps, right? If you have Chuck E. Cheese token, maybe you say, hey, 10 plays cost $10. You can pay with your credit card here. You can create a situation where people can't actually withdraw ETH, right? So you don't have to deal with KYC in this situation. People can't money launder money through your app, right? But you can still charge them for using your application in a way that they're comfortable with and they're familiar with. And finally, you can onboard users using Web 2 technology, right? You can have an application where people sign up using username and email, something people are already comfortable with. So this is actual footage of a new developer trying to build a production dApp on Ethereum today. You could expect that, right? So the other half of this question is developer experience. Like I was saying before, you can roll your own MetaTransaction solution, but good luck, right? We all know how difficult it is to build these applications because we are the front runners, right? We are the first people to be building these types of applications, and it's not a smooth process, right? There's a lot of difficulties that we have to deal with. We have to go to Stack Overflow, we have to Google around, we have to find our own kind of solutions. Many of us are doing sort of non-standard hacky things, just trying to get to MVP status right now so we can get it out there. If we were going to wait for Web3 to be, a Firebase level experience or any other of these, mature technology experiences, we would be waiting a long time, and we won't be those first movers building those applications of the future. So, how does OpenZeppelin come into this question, right? And for us, it is all about the tools that we use to build on. We've been providing for years now the OpenZeppelin library of standardized smart contracts, which allow you to build complicated financial applications without fear that while you're sleeping at night, somebody's going to re-enter your contract and drain everything, right? We're taking the same methodology of dealing with how we improve the developer experience and applying it now to GSN, to MetaTransactions. So as part of our rebranding, we've separated our offerings into three pieces. We have contracts, which are our library of modular, reusable smart contracts, which you probably already know. Our SDK, which inherits from Zeppelin OS, a tool that allows you to build upgradable smart contracts and EVM packages. So you can do things like fix your code in production or iterate quickly within a team without having to redeploy and have new addresses. And starter kits. Starter kits are one of our newest tools which allow you to get started with a production grade base for your application in one command. You get a React app, you get our OpenZeppelin library, you get numerous tools, Rimble from Consensus for your front end, all of this bundled into one. But let's go through our tools really quickly right now. So we have OpenZeppelin SDK. This is a complete CLI that is available today. You can take it you don't have to actually do this right now, but one line, you install OpenZeppelin CLI. You have features such as OpenZeppelin transfer, balance, send transaction, call, right? It's an interactive CLI. This sounds pretty simple. Oh, of course, OpenZeppelin send transaction. You can also do OZ for short, by the way. You don't have to always type OpenZeppelin, right? But if you remember in the past, if you deployed a smart contract and you wanted to test it, you'd open up your console and you'd be like, okay, let instance equal my app at this address. Oh, wait, doesn't work. Why not? Oh, you have to await it. Let instance equals await my app at this address. Great, it just returns undefined. Then you're like, okay, then I want to make a transaction, web3.eth.send, right? It was a pain. And if you changed your contract, you'd have to do it all over again, right? So doing the simplest thing, okay, I just want to fund another account. You got to go in. You have to make the whole transaction. Now you can do that in one line. For me, it's been a lifesaver. As soon as you try it, you'll see that it's a lifesaver. Of course, also in the CLI, you can do upgrades, contract creation, and more. This is available today.
Is that stuff safe? Like, would you deploy contracts to mainnet?
Yes. Yeah, you can not only deploy contracts to mainnet, you can manage your contracts on mainnet. You can call your contracts on mainnet. You can upgrade your contracts on mainnet directly from the CLI.
Can you verify them with MetaTransaction?
Yes, we have a command, OpenZeppelin verify, that allows you to do that. I believe that they are working. We have a number of engineers in the room who, if there's some particular use case that you want to ask about, we can double check. But yeah, should be working. You know, one of the important things to us is that these tools that we're presenting today are available for you to use today, right? None of what I'm talking about today is a promise in the future, something in 6 months we'll have, get really excited about it, and never hear about it again. Everything today is available today. OpenZeppelin network. This is on the front end. Well, you don't have to actually use it just on the front end, but this is a tool that allows you to get your Web3 easily inside your projects. When we're building GSN, one of the things we realized is that once you get on the front end, the decision to use MetaTransactions, the decision to use directly the Web3 network is going to be one that's going to have a lot of complicated code. So we simplified this and provide you with a simple tool that gets you your Web3, that you can build your contract instances, that you can use MetaTransactions all in one. As you see here, there's a small typo. It should be Web3 contacts as well. Oops. But to use GSN, to use MetaTransactions, it's enough to plug your provider into the use Web3 network and send in an object that says GSN true. Now, all of your contract transactions are automatically MetaTransaction enabled using the GSN network. That's all you have to do. You don't have to change the rest of your code. Everything works as expected. Of course, there's some additional things to help you out here on that object that you create. You have your accounts, your network ID, your network name, your provider name. Lib is your Web3, and connected is a Boolean which tells you true when everything's been set up. So now you can simply just wait to hear connected true, and you know your app is ready to go. We also have subscriptions that allow you to do things that when the network ID changes, you can reload your interface. You can do whatever you want to do. So it's very easy, and this is available for you to use today.
What GSN stands for?
Gas stations network. OpenZeppelin contracts, right? This is what you already know, the OpenZeppelin library audited smart contracts, but we have upgraded it. We have added GSN support. Now, to make your smart contract MetaTransaction capable, all you do is inherit from GSN recipient. And your contract, with the addition of this function, accept relayed call, is now MetaTransaction enabled. That's all it takes to make your contract smart MetaTransaction capable. This, of course, is available today. It's available right now.
So does that mean like the existing contract we have today, we have to refine it?
Yeah, for existing contracts that you have already deployed, you will have to think about what you want to do to make them MetaTransaction enabled, capable. So if you used Zeppelin previously, you could upgrade your contract. If you haven't, you'll have to think about either migrating or creating another solution where you perhaps have like a contract in between that speaks directly to your contract, and that one is MetaTransaction enabled. That's something that a lot of people will be dealing with for already deployed contracts, and you can talk to us about the different solutions that might be applicable to enable that sort of transition. Of course, testing is very important, so we have launched for you OpenZeppelin GSN helpers. Right? MetaTransactions are complicated. We're making them simple and easy for you to use, but they are difficult under the hood. Right? So what we've done is we've built out a tool of GSN helpers that allow you to be able to test these things. Right? So in one line of code, you can deploy a relay hub, you can run a relayer, you can register your relay in the relay hub, and you can fund your recipient contracts. And this example that I have here for you, this is in code. So you can use this in Mocha, you can use this in Chai, you can use this in whatever JavaScript testing framework you're using. But also, there's a CLI. So you can do this directly from the command line if you want. You can deploy your relay hubs. You can run relayers, these things. This tool set is available for you to use today. And of course, the OpenZeppelin starter kits, right? So you can build your dApp today. This is as easy as you install the CLI, and then you can unpack your starter kit. And we have a starter kit now, which is GSN enabled, and that means that you'll have a MetaTransaction capable dApp right out of the box. Of course, we don't stop there. We have a number of web tools for you as well. The OpenZeppelin GSN Relay tool. This allows you to see through a convenient web interface on the OpenZeppelin site the relayers that are listed. I think it'll also be on the GSN site. We'll find out the link for you. I don't have it here right now. Basically, you can list all the available relays that are currently registered, and you can access them and see details about them, especially if you're running a relay or relayer. There's also a tool for dApps, right? One of the things that you'll need to do is you'll have to put up a balance to pay for the transactions that people are using your dApp for. So we have a convenient tool for you that allows you to top up your balance directly from this interface. So you could just use MetaMask if you're on the go or whatever like mobile browser that you have. This shows Rinkeby, but it's also live on mainnet, and I think actually now we're live on all the test nets. I think we're live on all the networks, all the things. All right, MetaTransactions, GSN, and user onboarding. Before we do that, though, let's just check into our poll really quickly. Find out who has been using it. All right, so have you used MetaTransactions? Our workshop survey. So 2 people have said yes, 9 people have said no. Of course, that's not really true because this is a MetaTransaction-powered application, so all of you have used MetaTransactions. And what's great about that is that you didn't know you were using the Ethereum network when you did it. Some of you did it from your phones, some of you used it from your desktop, but you made live transactions on Rinkeby using an application without even knowing you were using a blockchain application, right? A lot of our applications today are like crypto this, blockchain that. The users don't give a what it's running on, right? They just want it to work. So this is an application using our tools I built last Saturday in between a couple of our meetings in just a couple hours time, right? It was really simple to do, and it's that easy to do for your application as well. And that's the kind of user onboarding we want to see, right? The ability to talk to a room full of people, have them use the application, and there's zero friction in that. If any of you, did any of you open the console while you were using it? Maybe we'll just do that right now to see. This is the live demo part, so now something's definitely going to break. But if I just click yes, you'll see here we send the transactions. We get a lot of the data back from the relayers that it goes out to. You get the, I'm sure you guys are like logging into it now. But you can go ahead and see that that's what's happening under the hood. But of course, it never even occurred to you. So go back. Who thinks that's cool? Show of hands, right? Thank you. So let me go back to presenting mode. So we've gone through a little bit of this already. What MetaTransactions are, in essence, it's other people paying the gas costs, or in this case, the dApp developer paying for the gas cost to run the application. They're useful for the reasons that we've already seen. You can create these Web 2-like experiences and completely abstract away the fact that we're using blockchain from the user. GSN is the Gas Stations Alliance. Gas Stations Network, the group is called the Gas Stations Network Alliance, and that's a group around standardizing this, right? Like MetaTransactions do not belong to OpenZeppelin. We're building the tools for it, but if you have a company and you want to join the alliance, you're welcome to join the alliance. This isn't going to work unless it's standard, right? This is something that we all need to know how to use. It needs to be open so that we can all build these kinds of experiences. There's no lock-in on this. So now we'll go through the anatomy of a GSN transaction, introducing the tools, blah, 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 we already did that, and then code. We already did that. All right, so at the base level, and we're going to get a little bit deeper in this, and we can do like different levels. Also, if you have really tricky questions, we have a bunch of our engineers and team in the room, so we'll probably be able to answer anything. But your traditional transaction workflow, of course, you have your users. They make transactions to Ethereum. In the MetaTransaction flow, you have users, which make a request to a relay, and the relayer sends the transaction to the Ethereum network. All right, so let's walk through it. Our participants in this. Some animation. We have users, pink crabs. We have a contract. We have a relayer, and we have a relay hub, right? So the user, of course, is anyone who's using your app. Your contract is your smart contract that's MetaTransaction enabled. The relayer is the individual, the relayer that actually sends the transaction to the network. And the relay hub is the singleton smart contract that is on the network that you're interacting with that coordinates all this. All right, so step one. your contract if you wrote it, you have to deposit funds in the Relay Hub to pay for your transactions. Basically, that's like topping up your contract. Because the way it's been designed, you don't have to store money in your smart contract. And that's really important, right? Because the moment you start storing money in your smart contract, you have to take a whole different level of like cautiousness about how you're writing your code. So in this, the funds are stored on the Relay Hub, and whenever transactions are made, it's deducted from your contract's balance on the Relay Hub. When you deposit, it also essentially registers your contract there. 1A, the relayer now deposits stake in the Relay Hub to register as a relayer, right? So if you want to be a relayer, and anyone can be a relayer, you first have to put up some sort of like collateral in case you do something nefarious, right? There has to be something to punish you if you try and mess with the network. So in that case, what you do is you deposit some amount of funds on the Relay Hub as your act of registering, but it also acts as the guarantee that you're going to behave well. Because the way the system is set up is if you behave poorly, someone else can slash you and they get your stake. I like stake. Okay. Step 2, the front end, right? In this case, the user is going to represent the application on the front end, right? So the application gets a list of relayers from the Relay Hub. How that works is when you do register and you deposit the stake in the Relay Hub, it emits an event saying, hey, this is a new relay, and this is the conditions that the relay is going to like do business under. So the front end gets a list of all these relayers and then chooses which relayer wants to do business with, right? And it's actually up to you to choose who you want to do business with, right? There'll be in the future, I'm sure, thousands of relayers, and you can choose any one of them, or if you're running a relayer, you could choose your own. So step 2, the user gets a list of the relayers from the Relay Hub. Step 3, user selects a relayer and sends it a transaction request, right? So when they go click on counter increment by 1, I'm going to use you as the relayer. Here, I want to increment this by 1. You take it, you wrap it up, you do some things that we'll talk about, and then you submit it to the network. Step 4, the relayer checks the Relay Hub to see if the contract will pay for it, right? And this is an important part of the coordination. If I were just to say, hey, process my transaction, you'd be like, yeah, that's great, but are you going to pay me, right? The Relay Hub makes sure you get paid as a relayer. So when it checks the Relay Hub and checks this function, accept relayed call, basically your contract says, yeah, I'll pay for this transaction, right? Like I know this guy, he's cool, I'll pay for it, right? And at that point, the relayer knows no matter what happens now on, from this step forward, they're getting paid for doing the work. Will you pay for this transaction? No, relayer does nothing. Goes, all right, well, whatever. Yes, continues on the flow. So once approved, once it says, yeah, the contract is going to pay for this transaction, the transaction is made through the Relay Hub, right? So the user goes to the relayer, to the Relay Hub, to Ethereum, right? So you make the call through the Relay Hub. Step 6, relayer sends back a signed transaction to the user, right? Think about this for a moment. I say, hey, you're going to send this transaction for me, right? And you're like, me? Right? OK, I'll send your transaction. It's sent. But the front end doesn't know it's been sent, right? Like, has it been sent? So what we do in this case is that the relayer signs the transaction and sends it to the network. But it also takes this signed transaction and sends it back to the user, right? Because now the user has a signed transaction, a valid Ethereum transaction in their hand. And that means if maybe, yeah, I signed the transaction and then I turned off my relayer and went to sleep, it means I can now send this transaction directly to the Ethereum network myself. It's a valid transaction. The relayer is going to end up paying the gas for it. It's good. And that's very important because it's the only way the front end knows that its transaction is going to get processed. So step 5a, we go back to 5 once approved. Step 5a, the relayer receives payment from the Relay Hub, right? So now the relayer gets paid for having done this work. It's easy. There's a lot of steps in that, right? But it's something that we've abstracted so you don't have to directly deal with it. But of course, if you want to get your hands dirty, feel free. So this is a topic that comes up a lot, and there are a number of different ways to deal with spam transactions. So in building the GSN and the whole MetaTransaction system, there are a number of attacks that are laid out in the original EIP that was written by Tabuki. There are a number of highly critical ones that are already taken care of, and that's something that you don't have to worry about thanks to the design and the auditing process. Things like spam transactions, depending on the type of spam transaction, we believe aren't a huge issue. And the reason why is that if you're running a relayer, first of all, we believe that you should probably be a professional, right? So people running relayers do have to be a little bit smart. You can be burned on one transaction, right? Like someone could implement some sort of accept relayed call or whatever that somehow tricks the relayer into paying for something that they're not going to get refunded for. It's possible. But your job as a relayer then is to basically keep track of who burns you and never process transactions for them again. So the same way that the front end gets to choose who the relayer is, the relayers also get to choose who they want to do business with, right? So if I see that you just burned me, I lose, right? But I lose the cost of the gas transaction, right? So in this case, maybe it's 50 cents, maybe it's $1. But you can do that to me only once, right? So the idea is that the spam attacks actually don't scale. Because if you were going to spam the entire network, every relayer would lose maybe like 10 cents, right? But you would have to continue this attack, you would have to deploy a new contract, right? And there's no financial gain for you with the exception of like this idea that maybe you can like make transactions unavailable for the relayers and then run your own like more profitable relayer. But the reality is that that attack doesn't seem to scale. And we're certainly like looking forward to see if someone tries that. But in the worst case scenario, you as a relayer lose the gas cost of one transaction, right? What we expect to happen going forward is we expect that there are going to be professional relayers who kind of work like credit card companies in a way, where they essentially have this idea of like who is a reliable person to do business with, right? We also expect that large applications will probably have their own network of relayers, or they'll have service level agreements with particular relayers and get a special pricing, right? So the relayers generally will say like, we'll take 80% of the actual gas cost as like our fee, right? Well, maybe you can have a service level agreement with someone and say, hey, my transactions do it for like 5 cents. So there are the possibility of spam attacks, but in no way does that ever affect the user experience. And it doesn't scale, and at the max, it only costs relayers the cost of one transaction. But it's a good question, valid question. Do you have a question? Well, you certainly could, right? Like if you are thinking, hey, my app is huge, I'm Instagram on Ethereum, I have 1 billion people using it, why am I paying other people to process my transactions? Sure, run your own relayer, right? Absolutely, you could run your own network of relayers, right? That's not a problem. What the network of relayers is for in this case is that for everyone else who's running a DApp and doesn't want to also have to run a relayer, right? Because running a relayer is kind of like running a credit card processing facility, right? So it is a professional's job in and of itself. You can certainly do it, right? And if you have the infrastructure and you want to save that money and it's worth it to you, absolutely. But if you're not, if you just have a simple app, you get all the reliability of having an entire team that just sits and watching the relay server 24/7 without needing to actually do that, right? Because this decentralized network of relayers are always available for you. So as long as you're okay with it, whatever the fee the relayers are asking for doing the transactions, you have high confidence that there's always a relayer available to you. So why do the work? Sure. That's not our focus right now, but certainly if you're technically capable of running a relayer, you're technically capable of using our tools to help build that relayer for you. Yeah. Any other questions?
Who decided the gas price? And if it's a user, what happens if the relayer puts a higher gas price and then the user backs?
So basically, these are options that are configurable. So as a relayer, you can have your max gas price that you're willing to pay. So in this case, maybe you're really worried about spam attacks and you're okay with losing 10 cents on a gas transaction, but you're not okay with paying $1 or $2 to have the transaction go through and get burned, right? So you can adjust that on your side as a relayer. You also have the ability to configure these things on the front end, right? So the gas question is, how much are you willing to pay, right? You as the front end can never be like screwed more than you expect it to be.
If the relayer increases the gas price, put it to 1 is the gas. It will pay a lot, but then it will get refund from the user, and the user will get
So you set what your maximum is, and you're not going to get charged for more than that, right?
It's verified on chain.
Yes, yeah, this is all verified on chain. This is all, and there's actually some tools that help you in your smart contract to determine those things. Let's see where we are. Okay. Let's code. So this is the riskiest part of this presentation. So first of all, I don't know how well the Wi-Fi is working, so just to get a backup, take a picture of this. We're basically going to be following along more or less the quick start. But here are the 2 links, so keep them handy at your side. I'll probably be switching back and forth between them. A lot of these tools are new, so I don't actually know all the commands off the top of my head. We recently changed them, so just write this down, have it handy. Take a picture. You can use this to go through it as well.
Is the workshop going to be published online?
Yeah, I think this video is going to be published online. I think. Yeah. They're recording it. I personally don't know. I think yes, but I'm just in the video. I don't run it. All right. So setting this system up, right, there are generally 3 different parts, right? One relates to the relays. So you need to deploy a relay hub, you need to run a relayer, and then you need to stake in the relay hub, right? This is for relayers. For contracts, you need to enable MetaTransactions in your contract, and then you need to deposit to pay for transactions in the relay hub. Number 3 is you have to incorporate the GSN provider in your front end so that your front end is aware of MetaTransactions. Right? So let's set up our GSN environment. We'll deploy the relay hub, run relayer, and stake in the relay hub. So you can follow along with this. I'll do a little bit of typing on screen, but I know that's kind of sometimes annoying. But basically, you can install the GSN helpers, which hopefully you managed to do earlier. And then you're going to run a local blockchain. And then you're going to run a relayer for your platform, right? So the command npx ozgsn run relayer will actually go out and download the binary that's compatible with your environment, run a relayer, deploy a relay hub if one doesn't already exist on your local blockchain, and then deposit a stake for your relayer. So maybe I'm going to try and split screen this and show it to you at the same time. All right, so.
Quick question.
Yeah, sure.
When you work with the OpenZeppelin SDK and everything, do you still use Truffle and all that? And
We are becoming a bit more opinionated. And that's mostly because we have so many pieces, moving pieces now on our side that we need to begin to control a bit more the entire environment. We still, I think at the moment, use Truffle for tests. But otherwise, besides Ganesh, now OpenZeppelin SDK just uses a Solc compiler directly. We have our own format for your project, which is compatible with Truffle. So generally, no, we're still using Truffle for tests, but we're trying to move everything into our own ecosystem simply because once you have the MetaTransactions, once you have the upgrades, once you have all these pieces, it's hard to make sure they all work together properly without controlling the whole stack.
I wouldn't mind Truffle at all, but so and would you still use Web3.js and everything? Or
I mean, I don't think we're so opinionated, correct me if I'm wrong, I don't think we're so opinionated that you can't. right? Like if you're in love with one of these tools, GSN helpers will work with Truffle. The network provider on the front end, of course, that'll work with Truffle because it's not really like connected. Using the OpenZeppelin library of contracts to make your contract MetaTransaction capable, that'll still work with Truffle. So you'll lose the ability to do the upgrades, for example, the upgradable smart contracts, and you won't have, you could be running both at the same time, honestly, right? Certainly, like the SDK, the CLI, the ability to like do transactions directly in the browser, directly from the command line is pretty dope. So, it's up to you. We're not so opinionated that you can't keep developing the way that you already do. Has anyone typed this in? So I'll just give you an example right here. So let me run, hold on, let me make that way bigger. All right. That's okay, right? Okay. All right, so let's run Ganache really quickly. All right, fantastic. Let's open another window. Now I'm going to do NPA. Oh, I have to go into a project though. CD starter kit JSON. NPX OZGSN. Run relayer. I might have to install it first. Say, yeah, okay. npm install OpenZeppelin GSN helpers. I hear that. Is it working, not working over here? Let me take a picture of all of you because there's so many today. Nice. All right, I'm going to do this while we're still installing. Awesome. Definitely. Well, keep track of what you're doing. This is actually my second workshop this week. We had a workshop earlier this week, a talk earlier this week. So hopefully by the end of this week, people will definitely know MetaTransactions. Actually, we have a kind of funny story. We presented earlier in the week, and then for the DAI happy hour, Aave built a production app using our tools and the GSN on mainnet, and we didn't even know about it, and they were running it until they actually burned through all the money on the relayer because we didn't know. All right, so let's try this again. npx OZGSN run relayer. So in one command, as you see here, we've run a relayer for my platform. We've deployed a relay hub to Ganache, and we have staked our relayer in the relay hub. That was really easy, right? So if you're developing and you want to figure this out, that one command has done all of it. It's pretty cool. It's pretty cool. All right. So now we have a relay running. So smart contract, writing the contract and enabling GSN. So this is kind of the tricky, less fun part. So I'll see if I code along with you or just sort of show you and explain it. Because if I code, I'm going to be quiet while I'm typing and doing typos. This is pretty simple. So we start out with a smart contract that looks like this. We all know these favorite contracts, counter, right? Now, to enable GSN, to make it MetaTransaction capable, we simply install the OpenZeppelin contracts Ethereum package, right? Which you're free to do. If you were following along earlier, you probably already did it. If not, in your project, do this. Then we create new contract code, which I'll go to right now to show you what that looks like. All right. So before, this is our code, right? Contract counter, public value, function increase, that's it. Now, for the second step, oops. Hold on a second. Let me make this smaller. Oh, we don't need that right now. OK. So this is still our counter contract. Up here, we import from the GSN recipient contract, right? Now we inherit it. Counter is GSN recipient. And we include this function right here, accept relayed call. And this is the most basic function that you need to have included to make your contract metatransaction capable. In this case, we are simply returning this function, approved relay call. And this essentially returns, I think it returns the integer 0, which means everything's OK, we're going to pay for it. But it's in this function that you would write your logic to determine, am I going to pay for this call, right? And that seems like an easy question, but actually that could, depending on your application, be something that you really need to spend time thinking about, right? Because you need to figure out how are you going to identify your user, who you're willing to pay for, what transactions you're willing to pay for. Maybe you're willing to pay for the login transaction, but you're not willing to pay for the send emoji transaction, right? So it's inside the body of this function that you're going to make the decision whether or not you're going to pay for this call. But we give you help for that, right? So here you get the address of the relay. You get the address from who's actually sending it, the call data, what are they trying to call, your transaction fee that they're paying, the gas price, the gas limit, the nonce of the transaction, the approval data if you want to send some, and the max possible charge, which I believe there's a question over here about like how much are you going to end up getting charged, right? So we give you that information that'll get sent in, and then you can use that to help make some decisions. And then if you want to pay for it, you approve relay called. And if you don't want to pay for it, you return a reject relayed call. All right, that's the contract, all right? So yeah, we just went through this. Accept relayed call. Yeah, it should return a 0 as an integer. So there are some advanced features that we have here, which maybe you've been thinking about, right? Like, let's say we just had accept relayed call. You could say, OK, I got $100 in the relay hub. I'm going to accept this relayed call. It's going to be $100. And you do it, and you're like, yeah, we'll do it. And then you take your money out really quickly before the transaction's finished, right? And then you screw them. So we have some hooks here, pre-relayed call and post-relayed call, to both help you deal with this, but also to help you deal with some other interesting circumstances, right? Let's say before we were talking about paying in tokens, right? So let's say you want to charge your users DAI for paying for their transactions, right? Let's say you just have a service where whatever you want to call, we use an identity contract wallet, so now you can call any function on Ethereum, we'll pay for all your calls, but transactions are going to cost you 25 cents a pop, right? Well, charging them 25 cents a pop in ETH is going to be pretty tricky because the price of ETH is going to constantly be different and you're going to deal with a lot of pain. So let's say you just want to charge them in DAI. So in the pre-relayed call, what you would do is you would already move the DAI that you want from them out of their account into yours to hold it so they don't transfer it out. Then you do the accept relayed call. Figure out, are they going to accept it? Yes. And then in the post-relayed call, you can figure out how much did this transaction cost, and then refund them the difference, right? So let's say you're going to accept payment in ETH, and you're like, OK, I'm just going to withdraw $10 from you just to be sure, however much it's going to cost. The transaction costs $1, and then you return them 9, right? But you can do other things here in the pre-relayed call and post-relayed call, right? That's up to you, and these are tools to help you decide better who you want to pay for, what sort of actions you want to have happen when you pay for these things. Maybe post-relayed call, you only get 10 transactions paid for, and you sort of increment a nonce on how many transactions you're willing to pay for, these type of things, right? So these give you additional tools to do things before and after the transaction happens and the charge is made. Also, a side note, and this is very relevant for the gentleman who asked if we could use our existing contracts. There's a catch there. We cannot use the solidity, yeah, someone's shaking their head like, yeah. We can't use message sender. And we can't use message sender because, of course, it's not the user sending the transaction, right? It's not the user, it's the relayer. So message sender is always going to return the address of the relayer because it's the relayer signing these transactions. So we have two helper functions, message sender, message data, which will always return the real message sender and the real message data. And what that means is everywhere in your contracts where you would normally use message sender, you instead use underscore message sender. And when it is the user, it returns, like, for example, let's say the user actually uses MetaMask and calls the contract, right? It'll return the user. And let's say the user uses the relayer, uses MetaTransactions. It'll also return the address of the user, right? So in these cases, you do need to modify your contract with that regard. That's important to keep in mind. So to deploy the contract, you just use OpenZeppelin create. So let me go back to having an actual project open.
Can you quickly open the gist again?
Sure. Which one did you want? This one, you mean?
The contract that we will deploy, or should we deploy along?
Right. So let me go back up to the gist link. There's that one. Yeah, it should be this one here. Right? Okay, so let me make this big. Put it over here. All right. That is running. I'm in the workshop Dapp. So let me open this up in VS Code. No, actually, let's not. I'll stay here for now. Can you read? Is this large enough to read on the terminal side? It's presenting. Okay, so I'm just going to, oops. All right, so I'm going to go into our contracts, ls contracts, and we have this counter sol, right? So let's take a look at it. Oh, there's nothing in there, or I typed it wrong. CD contracts, sorry. Yeah. Right, so this is a little bit more here because this is from the starter kit, the GSN starter kit. So we have everything already in, but just commented out so that you can make the change yourself. So I'm not going to do anything here. You can continue using the code that you actually have. But so let's just show you how easy this is to deploy. So instead of, I'm going to type OpenZeppelin, but you can type OZ for short. OpenZeppelin create, right? So you can still use Truffle. Truffle clearly is still here hanging out. Right, so this is the CLI, right? This is the tool that allows you to do this a lot easier, like just the whole deploying workflow. So can we see that? People can see that generally? I feel like it's hard for you over here. But over here we can see it's not too bright. Okay. So you pick a contract to instantiate, counter. You pick a network. And this is defined by your network.js file or your Truffle config file if you have it there. Both will work. I'm going to choose development. Oh, sorry. I first have to init the project. So I'll do OpenZeppelin init. This is also an easy, yeah?
So you started unpack JSON, right?
Mm-hmm.
Can I see the command?
Can you see the?
Line.
Oh, the command for unpacking it? Sure. Where is it? We covered a lot of stuff. Okay. You should be able to do, oh, that's the manual one. You could do, did you do this?
Yeah.
Before? Okay. So you can stay on this one if you want. So basically the GSN package is this, but already done for you, the starter kit. But the starter kit would be,
I tried to do what you've done in the terminal and it doesn't work.
okay.
It doesn't find the GSM key.
Yeah, I had to OpenZeppelin create to get the contracts
Mm-hmm.
and stuff.
Yeah. What do you mean?
I think you had OZ create or something.
Right. Yeah. So what I did here is I did OZ create before I actually did OpenZeppelin init. I haven't created the project actually. So we can do this along together. Basically, I typed OpenZeppelin init. Actually, let me cancel out this and do that again for you. So open, are you in the workshop folder that you created earlier? Yeah. Okay. Let me close this one. In the workshop. From the first slide. Okay, so we're in OpenZeppelin init. And this is at the, yeah, thank you. All right. So workshop app, OpenZeppelin init. And this will create for us our project. So you choose a name for your project. I'm going to choose starter kit GSN. Project version, I'm going to just do 1. Project is initialized, right? That's pretty easy. So now, again, let's look at our folders here. So I'm just going to open up contracts again, CD contracts, so you can see that. Alice, we have counter, which we already have made from before. This is the code that's in it. This should be close to the gist. It's probably not going to be exactly it, but that should be fine for now. We've made a few changes in the past week, so some things are a little bit different, and we'll just correct them as we go along. So let me close this. And as per your specific question, let me pull up the command that you need if you just want to, yeah, this is the command I think you're looking for, right here. So if you missed doing the stuff at the beginning, you can also run open, as long as you have the CLI here installed. Let me zoom out. As long as you have the CLI installed, you can do OpenZeppelin unpack starter kit GSN, and that's actually going to give you everything, right? And that might actually be easier, so you don't have to like retype things later. Okay? Does not exist? Right. Sorry, here, let's do a new one. Yeah. I think that only works with Next, though. Is this correct, Paula? OpenZeppelin / starter kit GSN? Yeah, okay, so this should work. If you can give that a shot. 404? Let me just try that. We just changed some things, so let me open a new window. Failed to verify. Oh, without the leading at. OK. So without this leading at sign, in the next version, which we haven't pushed yet, you just do unpack GSN. It's working? Working for others? Maybe do this. This will be the most up-to-date version of the workshop that we're going through. So if you do this, we'll be all on the same page. So do it. I shall do it with you, actually. Oh, let's make a new directory. mkdir test workshop. cd test workshop. Right. OK, so make a new directory, because you're probably in your documents folder and there's already stuff there. And then do OpenZeppelin unpack OpenZeppelin / starter-kit.gsn. Download the kit. Yeah, let's do this. We'll all be on the same. No, not working for you? Live demos. Yay. Most people, though, have it working, right? What? Downloading, okay. Anyone else? All right, mine's downloading too. Let's see how long it takes. Let's see how much time we have left. How much time? We have 15 minutes left? Okay. So I'm going to go back in anyway. Give you an overview. So here we just saw that we have the counter contract, right? So now we're going to create it. These tools are really great because they're interactive, right? So we don't have to know the precise layout of our project. We don't have to know the precise name of things. It'll actually prompt us. If I had more contracts in my contract folder, it would actually give me the list of all the other contracts. So in this case, we only have one, so I'm choosing counter. Pick a network, development. The contract has been deployed. Do I want to call a function on the instance after creating it? If you would choose yes, it would give you the different options that you have, right? So that means when you're deploying something, because in upgradable smart contracts we don't use constructors, it's necessary to call a function if you want to set it up. So we give you the ability to call a function at the moment that you deploy it. In this case, I'm just going to choose increase counter by 10, right? So, and that sets everything up, creates our contract instance, and returns the instance. So in this case now we can do OZ call. OZ is the short for OpenZeppelin. Pick a network, development, counter, get counter. Yeah, right? So nice. It's not a big number. We didn't return to you a big number object, right? We returned to you what it actually is.
So this is basically the competitor to the Truffle console.
I didn't say it. You said it. So then you do OZ send transaction, development, counter, increase counter. Let's do it by 22. Transaction successful.
Can that debug too? Like if that failed?
Can you debug if that fails? Oh, but we'll put that on the list. But if it's something you're interested in, we'll bump it up the priority list. Do OZ call again, development, counter, get counter, 32, right? Pretty easy. So now let's see how our, great. Whose kit has downloaded? The GSN kit, still going? Still going? Mine downloaded. All right, well, wait a minute. In the meantime, though, I'm going to open this up. We'll go through this, right? So this is the starter kit experience for GSN and for all the starter kits is you basically, download, okay, so we're getting there. Is you basically do this a command, you unpack the starter kit, and everything you need to get started is already there. In this case now, we already have our Ganache running because I have it running from up here, right? We already initialized what we have to initialize here. So let's follow through. So I would go OpenZeppelin init app. This creates our project version, 1.0.2, let's say, project initialized. OK. So now we can check it out. This is what gets unpacked when we do the starter kit and unpacks. You can go to contracts and see what comes in the GSN. There's nothing here, actually. Oh, no. Else. So we have the counter again, like before. Nano counter. That's what we saw before. All right. OK, so also what we have, of course, is the React app. So let's open another window. I'm just getting my directory right here because I'm bad with my shortcuts. And now, see this, let me zoom in. See this client folder? We'll go to the client, npm run start. And that'll start up the front end for us, which I do not know why that's weird. Okay. So as soon as that starts, we'll see it pop up. I'm going to maybe go a little bit faster because we only have a couple minutes. Good? Right? This pops up. And this will actually give you, it's kind of like a basic format for you to get started so you can start playing with it right away. So let me go back in here. Test workshop. Right, so what we're going to do here is we are going to, let's see, OpenZeppelin create. We're going to create that counter contract again. Counter, development, call a function. In this case, yes, we do want to call a function, I believe, because I think we want to call initialize, maybe? Actually, I didn't see the, OK, so this sets the initial instance. Then we go back to our React app here. And in this case, we are using MetaMask just because we're doing development. Oh, sorry, not Ringsby. I want to do localhost, share address. All right. Let me deploy. Actually, we already deployed it. Hard on. Let me check. You have to upgrade it first? Oh, OK. OK, so what do I need to do to upgrade it first?
Go to counter so it can apply.
Oh, OK. Hold on, then. Let me go that. So I'm just uncommenting the stuff that's commented out. Do I need to uncomment this?
Yeah.
Yeah, OK.
And on the top of the package and inheritance.
OK, so what we're doing is in the contract that we have that's in the GSN file, you actually need to uncomment the stuff that has been commented out to get started. Oops, but not that. I think that looks good. We want to enable these other functions, the accept relayed call, the set relayed hub address, right? We need those as well. So let's go back. And because we are doing it live, we'll do, is it still upgrade or update? Upgrade. Update. Do OZ update. So now actually what we're going to do is we're going to upgrade that contract that we already deployed. And we have undeclared identifier. Do we not have, where?
Inheritance with line. Like you need to
Oh,
inherit
yeah, sorry. See, does that make sense? OK. So basically, I had the wrong counter contract line at the top. So we'll go back and update it again. Hopefully, it should work this time. Development. We're going to upgrade all instances. If you notice, this is a pretty easy way to be able to upgrade your contracts. Right? So that's upgraded. So now it should work.
And now we have to call another method which called is set relay hub because our contract wasn't GSN capable, and now we update it to be GSN capable, but it doesn't know where GSN hub pointed out. That is why we have to call this method, and we're gonna use this OZ-CLI method called send transaction.
Yeah. So essentially, what we have to do is we have to tell our contract where the relay hub is. Even though the address is the same everywhere, it's still important to tell it because you could be using another address. And that'll be this function, initialize, or the set relay hub address? OK. Set relay hub address in this case. You'll notice actually the event was emitted, which is nice. So we don't have debugging, but we do have events. So we go back.
Now we also have to make slight modification to the front-end source code because initially this application works with MetaMask, but for MetaMask you would use injected provider, but we don't want to use that. So we will go to a source file called app.js, and we will show you how easy it is to switch from MetaMask Web3 provider to GSN provider. Uncomment all the lines starting from line 20 to from line 27 to line 32. this is how you declare Web3 provider for GSN. Basically, we specify a local Ganesh address, and then with GSN properties, we set def true to set it in development mode, and we also set a sign key, which is in-memory key, which will be used to sign our transaction, but it doesn't need to have any balance.
Right, and that's actually an important thing, because the user still has a key pair, right? But this key pair is no longer important and no longer holds ETH, but you do need it to sign the message that's sent to the relayer. So in this case, we have another useful tool that comes out of the OpenZeppelin network package called Use Ephemeral Key, right? And this generates a key pair that you can then store in local storage, you can store in a backend database, or you can just use it for now and throw it away later. But that's very important, right? Because here, when we use GSN, we're sending in the sign key saying this is what we're going to use to sign. That is so that you don't need to use MetaMask at all, right? If your users do have MetaMask, but you still want them to use MetaTransactions, you don't need this sign key. And instead, what will happen when you try to make a transaction is MetaMask will still pop up, but rather than needing ETH, it'll pop up a request to actually sign a message, which I think we can show.
Just before that, we also have to comment line 34, because this is how you get a MetaMask web, for instance, but we don't need it anymore, because we're going to use the GSN. It's now safe and should be fine.
Right, so we reloaded here. We have to fund the contract. If you remember that step, our contract has to have a balance on the relay hub. So let's go back. We're just going to copy and paste that. That's the GSN helpers, OZGSN fund recipient. You have -- recipient, and then the address of the contract. Simple. Should be funded now. We refresh this. Now you can see that we have a balance, right? So to increase the counter, simply click it, and we've increased it, right? So we're interacting directly with your Ganesh contract right now. So if we go in the inspector, you can see what's sort of happening here a bit more. So let's go in. I'll add something. If we get rid of sign key, true, right? Increase counter by 1. That still works. And let me do a hard refresh. Why does it still work? Not sure why it still works. Normally, it should pop up MetaMask. We might be caching it. I'll figure that out later for you. Anyway, normally, that's what you would do, and the sign key gets stored for you. But to show you a little bit more of what's happening here, console log. Really quickly, before we're out of time completely. Right. So to peel apart this object to look into it better, here are your list of accounts, right? This is your Web3. This is your network ID. This is the name of your network. This is polling. Basically, that's how we continue to get updates. This is your provider name. Normally, you would see MetaMask here. In this case, because we see GSN, we know that it's now MetaTransaction enabled. And that's very useful. So this is what you would use as your object to get everything that you normally need. So if you remember from your front-end development, normally we would use that utils file called getWeb3, and it has a lot of different if statements in it. Now you really only need this line. If we comment this out again, and then instead we re-enable this one, use Web3 injected, and we go back, hopefully it doesn't just magically work, and we'll see the difference. All right, ignore that actually.
Yeah, you need to comment.
Sorry, what?
33.
33. All right, so we're missing something there, but we're not going to get into that. So it's 12. Workshop's supposed to be finished. Please, we know we didn't finish entirely with this, so come up to us and ask us any questions. We have that photo that you took earlier on that showed the 2 walkthroughs. That'll give you a complete overview of how to do this step by step. documentation on the website, you'll be able to actually see how to build that from scratch. So you can build the front end, you can build your contracts, you can build the meta transactions.